Let's go to Lico 966, Vowel Spellchecking. For this question, give us a word list, and we want to implement a spell checker to convert a query word into a correct word. So there are three rules. That is, if this query, for example, query has a match a word, um, let's look at in addition in the following part. When the query exact match a word in the word list, case sensitive, you should return the same word backwards. That means the first rule, if we match which word is the same in the word list, then return this word. If the query has some kind of match a word up to the capitalization, you should return the first matched in the word list. So for example, we have KITE, right? So for this one, you see this one, right? This one matches this, but we just return this, the second rule. But because we didn't find the first rule, right? In this kind of word list. So the second rule is that we match the first. The third rule is that when the query match a word up to was arrows, you should return the first, which map the word list. So for example, we have which one? KETO, right? KETO in the last one, KETO. There is you see they have same K and T, but the E and O, they are vowels, right? Because we didn't find a keto in the word list. And also we didn't, so the first rule doesn't satisfy. So also we didn't see any capital KETO or those kind of different capitalizations difference in the word list. So the second rule doesn't satisfy. So, but the third one, right? Third rule, that is we can have E, which is a vowel, and I is a vowel, right? So it return the first one, which have the vowel spell checker. So we need to implement three rules. So for the first rule, we just need to, because that is case sensitive, we just need to use that set, right? That uh rule we call rule one equals new hash set. Yeah. And the second rule is that the um, the capitalizations, right? So that means that we can use a map, right? How can we do capitalization? We change all of the word in the word list um, to be lowercase. So only first rule doesn't satisfy, so we'll go to the second rule. And what it is stored will be the first index of this kind of lowercase um, word. So we uh, call new rule two, right? New hash map. So when the second rule doesn't satisfy, we're going to use the third rule. So third rule, what we can also use a map. So the map, the things that we have the KITE, right? The by the second rule, it already changed the lowercase, that is smaller KITE, right? But for third rule, we just replace those kind of vowels, also use a dot or sharp, those kind of different signs, and store the first index it appears. So we can also have a string and an integer, right? For rule three plus new hash. So what we do is that we let's have int I equals word list dot length. And what we do is that for int I equals to 0, I smaller than n, I plus plus, right? We're going to have string word equals word list I. So we're going to have rule one add word, right? And let's also write compose that rule to map. That is, we need to convert word equals to word to lowercase. So what we do is that if this rule two uh, contains key, doesn't contains key, right? Then we add the first one word. Then we're going to put rule two put. Um, we don't even need to put the integer, right? We can put the the string even, right? So that we can just uh check the result directly and use put the string, right? So put word to and the original one is this, right? And let's say if we can write a help function called word called to word three word, right? Just all be lowercase, but those kind of words change to some kind of dot sign. So we'll say if rule three doesn't contain key word, then we're going to have rule three add word for the list I, right? So we need a help function. The reason is that when we check, we should also have the two word three function, right? So we write a private string uh, two word three with string word. So array equals word to each array. So for int I equals to 0, I smaller than array dot length plus plus. If um, array I equals a I O U, a or array I equals e or array I equals um I, right? Because they are all lowercase, we don't need to worry about the uppercase or not, right? So array I equals O or array I equals U. Then we set this array I equals dot and return new string array, right? So this is the helper for row three. So then let's have int m equals queries length, and we're going to have int result equals new string m, right? That means that if it doesn't find by the three rules, we are going to set return for those kind of results will be empty, right? So we can arrange the field result as empty string first, right? Then what we do is for int I equals 0, I smaller than m, I plus plus, and the string query word equals queries I. Then we'll say if rule one contains query word, right? Then we're going to have result I equals query word and continue, right? And then let's get this one as lowercase. Query word equals query word to lowercase. If rule two contains key, QWD, right? Then result I equals rule two get QWD. And we also need to continue, right? And then this query word equals to WD3 query word. And if rule 3 contains key, build WD, then result I equals rule 3 get build WD. Continue. Return in the end, return result. Right? There is so that we use a map, right? So compose those map or set that is, for example, this is n, right? So this is O n time complexity, and uh, we have queries. Those is OM, right? So if the word average length is k, right? We may need a multiple by k. So this is OM multiplied K. This is ON multiplied K, right? Space is also uh, the linear, right? So ON because we saw the N word. Python code will be very similar. That's right, Python as well. So we need a rule one, right? Equals and rule two, rule three. And row one is a set. Row two, row three is map, right? Or we can use stick. And n equals length of word list. And what we do is that for I in range and word equals word list. So rule one should add this word, right? And word equals word to lower. Mm, so the things that if word not in root two, are going to have root two word equals word list. Right. Then we're going to have word equals to word three, word. If word not in rule three. Going to have rule three word post word list. Uh, of course, we need to define uh, rule three, define um, two word three and word three. Result will be string. So how can we write this one? Is we can use vowels equals set A, E, I, O, U. Can write like this, right? And return this one dot join. Use a dot for say in was else say for say in word. So this will be the two word three. And then so this we compose set row one, set row two map, row three map. Then we get the query length, right? Then m equals length queries result. Let's set uh, empty multiplied by m, right? So for I in range m, what we do is set query word equals queries queries I, and if query word in row one, then we're going to have result I equals query word. Continue. Let's say if then we're going to have query word equals query word lower. And we'll say if query word in row two, then we're going to have result I equals row two get a query word. And we'll write a query word equals to word three query word. Let's say if query word in row three, we're going to have result I equals row three get query word. Um, you can use this. And then in the end, just return result. Join if is not for if say in was else if else, right, for say word list not defined. This is line 10. 8. Mm, so the 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 things that we need to continue, right? So that means that if the first rule or satisfies, we should not do the second rule. If second rule satisfies, we should not do the third rule, right? So we should continue the result.